Hello, 8th graders. We're going to be working on exponents today, except these are no longer the exponents that you've worked with in the past, something to the extent of 2 cubed. We're now going to be working with both positive and negative exponents. So when we think of negative exponents, I want you to think of the Sioux Falls I-29 corridor. See, now you got Brookings up here, home of the best school in the world, SDSU. And down here, you got a school that's not even on the map, USD. Think of Sioux Falls as a fraction bar. If Mr. Schmidt goes down to USD, that's the equivalent of having me be really, really unhappy, a negative exponent. If I'm at USD, I'm really unhappy. What you need to do in this situation is I need to go back to SDSU. I need to go back to the numerator. And because I'm back in Brookings, I'm going to be feeling a lot better. And now I'm a positive exponent. So you can think of it as 3 cubed over 1, or 1 over 3 to the negative third. So if I'm down in Vermilion, I'm unhappy and I need to move up. When I move, I become a positive exponent. Now let's think of Jake Cheeseman. Jake Cheeseman loves USD. If he's down in USD, we'll make Jake a 5. Jake down at USD, he's very happy there. He thinks it's the greatest place in the world. Who am I to tell him that he can't make horrible life choices? But if Jake gets sent up to Brookings, Jake's now going to be in a really horrible attitude. Now he's a negative exponent, and now he's unhappy. So I want you to think of exponents in the same way of Brookings versus USD. If you got a jackrabbit down in Vermilion, they're very unhappy. They're a negative exponent. If you have a coyote or a coyote up at Brookings, they're going to be unhappy, and they need to move back down to Vermilion. Now, if you don't like the SDSU USD analogy, that's okay. If we think of problems like this, I want you to think of negative exponents equal fractions. That's the other thing to jump to. Negative exponents mean fractions. So in this example, negative 2 cubed would be the equivalent of negative 2 times negative 2, which is the answer of positive 4. In this bottom example, negative 2 to the negative second power is the equivalent of this number in the denominator. It means a fraction. So when you see negative exponents, think to yourself, we're working with fractions, not negative numbers. If you notice, both of these had positive answers, even though we had negative exponents. And I even have a third way to prove it to you. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 4. 2 to the first, that's 2. If we notice from each of these steps, we're dividing by 2. Well, 2 to the 0, we got to divide by 2 again, and we get 1. But the process continues. We can continue dividing by 2. 1 divided by 2, well, that's just 1/2. Process continues. Going down here, 2 to the negative second power, that's 1/4. So negative exponents mean fractions. Get that locked in your head. So, how are we doing on time? Not that bad. Now we can start looking at some examples of what this looks like as a problem. So, all of these, we have people who are currently in Brookings, and they're unhappy. We've got Jake Cheesemans all over here. 2 to the negative second power, that becomes 1 over 2 squared. Now we are back in Vermilion. Now we're happy. We can do 2 squared, and we get 1/4. 5 to the negative second, same process. It becomes 1 over 5 squared. We moved the exponent down. It became a positive number. So we get 1 over 25. Process continues. 3 to the negative third becomes 1 over 3 cubed, which becomes 1 over 27. And finally, down here at the bottom, we get 1 over 6 cubed, which becomes 1 over 216. Notice, nowhere in this process did we get negative numbers. It is possible to get negative numbers, but negative exponents do not mean negative numbers. They mean fractions. I'd like you to try these on your own and see how they go. For this one here, we've already done it. Hopefully you were watching. It becomes 1 over 27. This one down here, 1 over 8 squared, 1 over 64. Bottom right, 1 over 5 cubed, 1 over 125. Now this one's tough. This one, each of the numbers is going to get a negative 3 distributed. Now, both of these exponents need to move. So the 3 cubed goes to the top. And the 1 cubed needs to go to the denominator. 3 cubed, well, that's 27. 1 cubed, that's 1. 27 divided by 1 is positive 27. So, a little bit different on the fraction ones. So, these are about as tough as the problems can get. If we have this problem, 4x squared over y cubed, all over 2x to the 4th y. The first thing I want you to do is what we call and's method. If you ever got a variable sitting by itself, put a 1 there, because it means y to the 1st. Then, think of these as 3 separate problems. You got 4 squared times x squared over x to the 4th times y cubed over y to the 1st. Think of them as 3 separate problems. Well, 4 divided by 2, well, that's just 2. X squared over x to the 4th, well, if we have 2 x squareds on the top, and we get 4 x's on the bottom, it looks like that. And then we get y cubed over 1y. So we're going to put the y's in a different color. So now we get 3 y's on the top. Whoops. And we get 1 y on the bottom. So we need to simplify every value that we can. So I know that 2 of the x's can be simplified from both. And I know 1 of the y's can be simplified there. So on the top, I get 2y squared. And on the bottom, I get x squared. And that would be the answer. Okay? So it's a little tricky. But I want you to try one on your own and see how it goes. For this problem, we end up getting 9 over 6 simplifies to 3 over 2. The top we get x times x. The bottom we get x times x times x. For the y's, we get y times y times y. And on the bottom we get 5 y's. Now, many of you are already thinking, do I actually have to write out this step every time? The answer is no. If you can understand the process of what we're doing, you do not have to write out this step. I simplify 2 x's here. I simplify 3 y's there. And I end up getting 3 on the top. The bottom, I get 2x times y squared. So, exponents are hard. They're going to take you at least 3, maybe 4 days. Make sure you are asking lots of questions. Let me work through the problems with you, and then we will be able to understand them in time.